Hi everyone, today we're going to start 3.3, which is prove lines are parallel. And our goal is to use angle relationships to prove that lines are parallel. Converse theorems. If two lines are cut by a transversal so that their corresponding angles are congruent, or their alternate interior angles are congruent, or alternate exterior angles are congruent, consecutive interior angles are supplementary, then we know that the lines are parallel. So yesterday we talked about that if the lines are parallel, then these are all true. So now we're talking about the opposite. If we know that these are congruent or supplementary, then the lines are then parallel. All right, so let's find the value of x that makes line M parallel to N. So we want to figure out what value of x that will prove that M and N are parallel. So let's start with what types of angles are these? They are corresponding angles. They're in the same position in the cluster of 4 angles, which means they are congruent. So 3x plus 5 is equal to 65. I'm going to subtract 5 from each side. So 3x is equal to 60. Therefore, x is equal to 20. Can you prove that lines A and B are parallel? Explain why or why not. So to prove that these lines are parallel, they need to be one of our specific cases. Are the corresponding angles congruent? Alternate interior angles congruent? Alternate exterior angles congruent? Consecutive interior angles, are they supplementary? So looking at angles A and B, what type of angles would these be? Well, they're alternate exterior angles. So alternate exterior angles. These tick marks mean that those are the same measure. So since those are congruent, therefore we can prove yes. Line A is parallel to line B. So let's try another. Can we prove that lines A and B are parallel? Explain why or why not. What do you think? Well, we can prove that these lines are parallel. So the answer is yes. And why? What type of angles are these? They are corresponding angles. And we see that they are congruent. So since the corresponding angles are congruent, using our converse theorem, we know that these lines are parallel. Can we prove that lines A and B are parallel? Explain why or why not. All right, so I have angle 1 here and angle 2. And if we look at here, it's telling us that these measures, when we add them up, they're equal to 180, so they are supplementary. So is this true? The answer is no. These are alternate interior angles, which means if these two lines were parallel, those would have to be congruent. So since they're not congruent, they're supplementary, we cannot prove that these are parallel. So this is an example of a situation where the answer is no. So alternate interior angles are congruent, not supplementary. I'm just going to put sup. Is there enough information to prove that the lines are parallel? All right, so very similar to what we were doing in the previous examples. So for number 4, what do you think? Is this enough information, yes, or not enough, no? The correct answer is yes. And these are corresponding angles. And if they're both x, that means that they are the same measure. How about number 5? Is there enough information here? Yes or no? The answer is no. These are not, none of our special cases, so we don't know anything about these angles, even though they are the same, they're congruent. That is not one of our ways to prove that these lines are parallel. So our answer is just no. And number 6, is there enough information here? Yes or no? The correct answer is yes. These are alternate interior angles. And we see that they're congruent. So that means that there is enough information to prove that those lines are parallel. Transitive property of parallel lines, this is the last thing we're going to talk about. If two lines are parallel to the same line, then they are parallel to each other. So in our example here, if we know that P and Q are parallel, we also know that Q and R are parallel. We then know that P and R are also parallel to each other.